Hello. So today we're going to talk about atoms. Some of this information should be a review from biology in previous years, but some of this information I think will be new to you as far as the arrangement of atoms. So by the end of this lecture, here are all the things you should be able to do. Alright, so first of all, what is an atom? Typical definition that you've heard before, I'm sure, smallest unit of matter. So this is the smallest indivisible piece of a non-living thing. This is also the smallest form of an element. So each one of our elements on the periodic table is composed of a different one of these atoms. And also, an atom is mostly empty space. So we're going to talk about the subatomic particles of it, but altogether it mostly is just empty space. And here are some of our examples of elements we'll look at this year, just to give you an example. So we have our carbon, our chlorine, sodium, and here is potassium. So each one of these is composed of a different atom. Alright, so subatomic particles, again, this should hopefully be a review. So I would suggest drawing this diagram of an atom in your notes. So protons we have in the middle, these are positively charged. Neutrons, of course, are neutral, and then those two together compose the nucleus of an atom. The electrons on the outside are negatively charged. Alright, so let's talk about how to draw one of these atoms. Again, hopefully a review for you. So let's start with just talking about the nucleus. Don't forget that our atomic number for an element is the number of protons you'll find in the nucleus. So hydrogen, for example, atomic number 1 has 1 proton. The other number you'll find on your periodic table is the atomic mass. This is your number of protons plus neutrons. So by your atomic number, you know what that proton number is. So you can just subtract that from the atomic mass to find how many neutrons to put in the middle. Also, something to keep in mind, the neutrons and protons do make up the mass of an atom. Electrons are so small and so light that they're negligible. Alright, so the electrons now. The number of electrons you also can get from the atomic number. That will be the same as the number of protons, because an atom on its own is neutral. The number of positive charges will be equal to the number of negative charges. Something else, and this may be new to you, is that the period on the periodic table, which are your rows going horizontally, that actually tells you how many shells the atom is going to have. So hydrogen and helium, they're in that first row, so they only have 1 shell. If you go down, everything in the next row has 2 shells, and so on and so forth. Alright, so what exactly are these electron shells? These are just the levels around the nucleus where electrons can be found. So for this class, and typically for chemistry, it's easiest to think of this in terms of our Bohr model of the atom, where it sort of looks like planets circling the sun. But keep in mind that these electrons don't actually follow an exact path. This, in reality, is just an area of probability where they can be found. And that's something we'll talk about later in the year. Alright, so best analogy to think of atoms are like onions. So I would also suggest drawing this diagram in your notes. So here are different electron shells of an atom, as well as how many electrons they can hold up to. So this might look different than anything you're used to seeing, 2-8-1832. Again, this will make more sense later in the year when we talk about electron configurations. But keep in mind your octet rule still applies, that besides this first shell with 2, the rest of these only need 8 electrons to be considered stable. And that stability is just how much does the atom want to bond with something else. Alright, so let's do a little practice. Go ahead and pause for a minute and try to draw these 3 atoms in your notebook. Alright, so I will give you carbon. And for this, it's okay if you just want to write the number with a P and the number with an N to represent your protons and neutrons. But the electrons you should draw on your shells. Okay, so let's talk valence electrons, another word you're probably familiar with. So these are the electrons located in the very outermost shell of an atom, and these are the ones that will be responsible for bonding. And we'll talk about both covalent and ionic bonding this year. So the valence shell is what we refer to as that outermost electron shell. Another term to keep in mind. So go back to those 3 diagrams you just drew, the carbon, hydrogen, and sodium, and go ahead and label how many valence electrons each one of those has. Do you notice any patterns? Okay, so here is an easy trick that you can use all year. So for our main group elements, and I'll show you those in a second, the group number of the element will be equal to the number of electrons in that outermost shell. The core electrons, which are just the electrons found inside of that outermost shell, they also show a pattern across the rows of the periodic table. Alright, so here we go. Let's look at this. So here we have our periodic table. And our main group elements are going to be these ones closest to the top, ignoring the transition metals and the lanthanides and actinides. So for valence electrons, anything in group number 1 will have 1 valence electron. If it's in group 2, it will have 2. And then if we skip over 3, 4, 5, 6, 7, and 8. Okay, so write these numbers on your periodic table. So for each of these rows, any element that's found in that row, that's how many valence electrons you're going to have. Use that trick all year. As far as our core electrons go, so those also actually show a pattern. So the core is anything not in that outer shell. So if we come over to our second row, they will have 2 core electrons. The third row will have 10. And then that third row is actually going to have 18. And you can just know up to that point. So that's anything in this row. So lithium, beryllium, boron, carbon, they all will have 2 core electrons. So that also hopefully will be helpful to you. Alright, so summary, this is what I would like you to do for practice for all of this information that we'll talk about when you come to class. So this you're going to do for element 34 on the periodic table, A through F. Alright, and here's one more thing just to give you an idea of the size of an atom. So we're going to zoom out and compare this to the size of some things you learned about in biology. So we'll start with our carbon atom, and then here we have some familiar molecules: tRNA, hemoglobin, a ribosome, one of your organelles, viruses, our powerhouse of the cell, bacteria, chromosomes, and then all the way out to what you can see.